Assalamualaikum and greetings to Doctor. My name is Nur Shafika Adlina Betty Samsudin and my ID number is SA18031. So for the first part, I will share about the whole research in general. So aside from energy generations, direct CO2 emissions from automobile transportations and industrial processes are significant to CO2 emissions. Moreover, the objective of this research are to discuss the process of CO2 conversions into methanol and also to study the future prospective and applications of methanol. The methanol could be used as a car fuel or combined with gasoline to create a high-octane efficiency fuel with lower emissions. The methanol also a crucial component in biodiesel, a sustainable fuel that can be used instead of blend with regular diesel fuel. The combustion of fuels for electricity and heat is the major sources of emissions among human activities like industrial and residential demands with 43% and 26% respectively. And then, as a result, methanol has emerged as one of the most promising fuels due to its efficient combustion and inexpensive cost when compared to other fuels. Moreover, by using methanol as a fuel allows to reduce the emissions of undesirable toxic products such as unburned hydrocarbon. And then the methanol will be the best options for not only reducing CO2 emissions into the environment but also converting it into a valuable product. And next, the chemical industry consumes the majority of methanols, which is around 35% of it is used in the manufacturing of formaldehyde, and the remaining is used to make gasoline additive, acetic acid, methyl, and other compounds. The methanol production has just surpassed ammonia productions as the second largest sources of hydrogen consumptions.
My name is Nur Haswani Pentinawi. Next, I will continue for the introduction. This part I will go through about carbon dioxide emission, product produced from carbon dioxide which is methanol, and for the last is objective. Nowadays, carbon dioxide being more significant anthropogenic greenhouse sources. The major anthropogenic sources of carbon dioxide include burning fossil fuel, which is coal, natural gas, and oil. Here, I provide the example of major greenhouse gas emission by various sectors. The combustion fossil fuel and industrial process has the largest percentage sources of carbon dioxide. Aside from carbon dioxide, methane also major greenhouse gas which is emitted by natural process. The third major is nitrous oxide which is mostly caused by land use activity. Next, by turning industrial carbon dioxide into liquid fuel. Power to liquid device has promising technology which can produce methanol product due to efficient combustion. Methanol is renewable energy sources that get from carbon containing mostly carbon dioxide. Indeed, carbon dioxide used in chemical industry such as feedstock, solvent, and co-solvent. Methanol also is generated from syngas mixture of carbon dioxide, carbon monoxide, and hydrogen. Methanol can be produced by this reaction. Methanol synthesis from carbon dioxide in equation 1, carbon monoxide in equation 2 is mildly exothermic. Methanol steam reforming refer to inverse reaction 1 and reaction 3 that refer as methanol decomposition. The slightly endothermic, which is reverse water gas shift reaction in equation 3 that occurs side reaction to methanol synthesis. The objective for this topic is to discuss the process of carbon dioxide conversion into methanol. And second is future perspective and application of methanol.
Assalamualaikum, my name is Nurul Isa binti Khairullah, SA18028, and I will continue the part of the report which is literature review. First is carbon dioxide. Carbon dioxide is valuable as a chemical intermediate, a liquid refrigerant, and a source of inert gas. Carbon dioxide can also be fixed and stored in nature via photosynthesis in seed, soil, and plant biomass. Bring the carbon close to being evidence. Human activity cause net carbon dioxide emission to continue to rise. As a result, carbon dioxide emission would be a global problem that needs to be addressed immediately. The best way to deal with carbon dioxide problem is to use it as a chemical feedstock because carbon dioxide is plentiful, non-toxic, non-flammable, and easy assemble carbon resource that is very applying as a typical renewable feedstock for producing value product, value-added compound or fuel product in an environmentally friendly. Methanol used in 19th century for cooking, heating and lighting purpose. Nowadays, the chemical industry principal raw material is methanol. It's made in large amount as an intermediary in the manufacturing of formaldehyde, methyl butyl ether and acetic acid, and among others compounds. Methanol also has a good characteristic combustion, make it a safe and reliable fuel for car power by internal combustion engines. Methanol has been used in diesel engines. However, because of its low cetane number, it is not the best fuel to replace diesel fuel. The cetane number is measurement of a fuel ability to self-ignite at high heat and pressure.
Hi, my name is Nurul Farina Natasha binti Baharudin. My ID number is SA18039. I will present the method in this report. The first process is methanol production from natural gas. There are 4 steps involved in this process. The first step is feed purification. The feed in this case is carbon dioxide, which is from air pollution. In this step, there are 2 main feedstocks, which are carbon dioxide and water. So both require purification. This feedstock will also undergo desulfurization, which is hydrotreating process. Hydrotreating process is a process of removing the impurities. The second step is reforming. Reforming is a process which transforms the methane and the steam to intermediate reactant of hydrogen, carbon monoxide and also carbon dioxide. So in this process, carbon dioxide also added to the feed gas stream to produce a mixture of components, which is to produce methanol. So the reforming process is carried out in a reformer. The next process is methanol synthesis, which is the third step. There are 2 main chemical reactions which occur in this process, where it represents the exothermic hydrogenation of CO2 and CO2 methanol. The chemical reactions are shown in the slide. The last process is methanol purification. The crude methanol is recovered and then it will be purified by distillation at distillation tower, which is to separate the methanol and water. Next process is methanol production from catalytic hydrogenation of CO2. Some authors presented the first work on the hydrogenation of CO2 to create methanol by using homogeneous catalysts. So, in general, ruthenium complex with various ligands have been the most extensively researched homogeneous catalyst for this process. Other than that, cascade process has recently been employed to convert CO to methanol. Cascade process separated into 3 steps. The first one is hydrogenation of CO2 to formic acid, esterification of the formic acid to produce formic ester, and the last one is hydrogenation of the formic ester to make methanol.
My name is Shahira binti Abdul Aziz. My ID number SA18042. The next method for methanol production from CO2 is electrochemical reduction of carbon dioxide to methanol. Electrochemical CO2 conversion has been widely employed in laboratories during the previous few decades, but it has yet to be successfully applied in industrial operations, which is large scale. The electrochemical reduction process uses electricity as the primary source of energy to convert CO2 to useful compounds and fuels such as methanol. Many CO2 reduction studies on metal electrodes have been carried out using various circumstances and electrocatalysts. CO2 may be reduced directly in the electrolysis cell back to methanol using the electroreduction process in a single step as shown in equation in the slide. CO2 plus 6 hydrogen plus 6 electron to produce methanol and H2O. Besides, various electrodes can be used to produce methanol directly from carbon dioxide. The pyridinium ion is discovered to be a unique homogeneous electrocatalyst for CO2 reduction to methanol at minimal overpotential. At relatively low overpotentials, ruthenium and ruthenium modified by cadmium and copper at atoms, which is an atom that lies on a crystal surface, can be employed as an electrode for CO2 reduction. Ruthenium oxide is a potential material for use as an electrode in CO2 reduction to methanol due to its strong electrochemical stability and electrical conductivity. In addition, the photochemical reduction of carbon dioxide to methanol. The photocatalytic CO2 conversion process is a complicated interplay of photophysical and photochemical reactions. Several tests have been carried out to assess the capacity of various semiconductors and metal oxides to convert carbon dioxide to methanol. Granular silicon carbide has been shown to be a potential photocatalyst for CO2 reduction to methanol. By using a 355 nanometer laser, granular silicon carbide was evaluated as a photocatalyst to decrease carbon dioxide and convert it to methanol. As a result, they stated that a pair of competing processes, photooxidation and photoreduction, occur in the photochemical process. The last method is photoelectrochemical reduction of CO2 to methanol. The photoelectrocatalytic CO2 reduction technique combines photocatalytic and electrocatalytic processes. The production of hydrogen ions and electrons by solar irradiation of a semiconductor employed as a photocathode is a key initial step in the photoelectrochemical process of reducing CO2 to methanol. The proton exchange membrane was utilized as a separator in this complete cell to avoid format reoxidation at the photoanode surface, as shown in the figure in the slide.
Next, I will present about the application of methanol. The first application is methanol to dimethyl ether. One of the most promising technologies in the last 10 years has been the use of methanol as a C1 building block in the petrochemical sector, and the large portion of its output is utilized in the manufacture of DME as an alternative fuel. On the other hand, dimethyl ether may also be used as a chemical feedstock in the production of a variety of products.
Next, I will present about the future perspective. Conversion of carbon dioxide into an energy product such as methanol will use a huge amount of collected CO2. Furthermore, the methanol produced may be utilized instead of fossil fuels, lowering reliance on fossil fuels and contributing to the market expansion of carbon dioxide use. As a result, in the future, the power required for large-scale electrochemical carbon dioxide reduction processes can come from a variety of renewable energy sources such as hydro, wind, wave, geothermal, tides, and others.
So in the last part, I will conclude overall of this research. So methanol is a significant primary chemical product that is utilized as a chemical feedstock in the manufacture of variety of key industrial chemicals. There are two main chemical reactions which occur in this process where it represents the exothermic hydrogenations of CO2 and CO2 methanol. Currently, many process approaches are being investigated for the hydrogenations of CO2 to produce methanol, which are homogeneous catalysts and electrochemicals. Other than that, the cascade process has recently been employed to convert CO to methanol. As a result, the conversion of CO2 into an energy product such as methanol will use a huge amount of collected CO2 despite the fact that the market size for methanol is theoretically vast. By combining methanol with these chemicals, it may be utilized as an intermediate material to create hundreds of methanols and methanol derivatives products that are employed in almost every aspect of our life. That's all. Thank you.